All right, good afternoon, everyone. I hope everyone's having a great day today. So before we jump into Chapter 13, I want to make a couple quick announcements. We will finish up with the unit today. We'll have a review tomorrow. So because the review is going to be tomorrow, of course, the quizzes for Unit 2 will be due on that day. Please make sure you submit them by 11:59 p.m. You don't want to get zeros on the quizzes. Like I said, it should be pretty straightforward. Just a standard vocab quizzes as you've had before. But beyond that, I also wanted to kind of let everyone know I sent out a article, breaking news today actually. Slack filed a lawsuit against Microsoft. They accused Microsoft of engaging in competitive or anti-competitive practices, where basically, Microsoft kind of pushes Teams on a lot of people. And, Slack alleges that's an unfair use of their kind of power and market dominance. So due to the schedule, just kind of going through it. So we've got the test on Friday. Next week, we're going to have pretty beefy chapters, so we won't really have a lot of class time to really have a debate or discussion. We're not having class Friday, so I apologize for that. But basically, all you'll have to do is just write 1 or 2 paragraphs about kind of what you think about, the whole Slack lawsuit. And then in a broader context, what do you think about the use of anti-competitive practices? Is that something that government should regulate? Should they not regulate it? Why not? Just a reminder, I'm not grading your opinion. I'm just grading that you submitted an opinion. So don't have to worry about, anything like that. Any questions before we begin today? Certainly feel free to interrupt with any questions at any time. But today we'll be talking about Chapter 13. And in this chapter, we're really going to tie a lot of the earlier ideas together, where we're actually going to show how do organizations actually acquire information systems? How do they get them? That's a pretty important thing to do, especially from a managerial perspective. So there's a lot of different ways. They don't have to make every single application. They could go out and purchase applications. And we're going to cover some different approaches kind of regarding that. So more specifically, we'll be talking about IT planning. How do organizations plan for their IT departments? How do they make sure that their IT department aligns with what their company's doing? There's lots of different things to discuss there. We'll also talk about where you can actually purchase applications. What sorts of approaches can you take to acquire an application? And then we'll also talk about the system development lifecycle. And one more thing we'll talk about today is the technology guide for software. It's highly related to what we're talking about today, so I just went ahead and combined them into one unit. So this is a kind of humorous video. Unfortunately, again, I can't play it, but it basically has Dilbert here is given a piece of wood with a nail in it, and his colleague here says that it's his power supply, but he didn't know how to make a power supply, so he just put the wood in the nail and called it a day. And then he said he's going to give him his files while he goes on vacation. So it's a pretty humorous little clip there. And the whole purpose is kind of illustrate that the software has to work. It has to have a function. And whatever the function is, it has to be something the organization can, basically capitalize on, find useful. So that's just a kind of humorous little way to get started with the lecture. And probably more humorous than the strategic planning cycle, but the strategic planning cycle is very important. So, the first thing we want to do with a strategic planning is we want to figure out what our organization's goals are. In other words, why is our organization in existence? How can we further their goals and allow us to kind of become, a market dominator, hopefully. So with that, we want to figure out, based on the goals, what do we want to accomplish? What outcomes do we want to see? These are going to be stuff that are going to be measurable and they're going to be actionable, but they're going to be still high level. I mean, this isn't at the strategic level. So we're starting off with our goals, then we're seeing how do we know that we met those goals? We're going to go into strategies. How do we get to those goals? So we've already determined what we need to accomplish, but how do we accomplish that? That's going to be our strategies. We have measures and targets. These are going to be very actionable. And then we get the results and we reflect on it. And it's basically a cycle, so it starts over. And all this is kind of central to the idea of a mission statement, the idea of what our organization does and why it does it. So that's going to be very important for information systems because there's a whole idea of having, IT alignment or IS alignment, where basically the IT department in the organization needs to be aligned with the organization. So for example, imagine you are a cost leadership firm. That's your corporate strategy. And your IT department was focused on, having things that no other firm does. that's not aligned very well with your department, with your organization rather. There's a misalignment there, and that could be very devastating for many organizations. So we want to avoid that. Basically, we just want to make sure that whatever we have for the organization, we align the IT and IS with that. So this is going to go all the way up to things like architecture of the, maybe data center, just the general kind of determination of what IT are they going to purchase. That's all going to be kind of related to this. And ultimately, the goal is to make sure that we're allocating our resources in a way that aligns with our corporate strategy. So that's really the whole purpose there. Now, with that, we're not just going to stay in the strategic level all day. We're going to look at this in an operational context and look at the operational plan. So basically, there's going to start off, if you have an operational plan, it's probably going to start with some sort of mission statement, where we determine what the purpose of the IT investment is for the organization. And this is going to be very broad. Even though it's an operational plan, it's still going to start with a very broad message. And then below that, we're going to define what our IT environment is, or what our IS environment is. I'm going to use those interchangeably today. But typically, if we're talking in the context of a firm, we're probably going to say information technology, regardless of whether or not we're including people and processes. We're just going to go ahead and call it IT. That's what happens in practice, at least. So anyways, we're going to outline our environment. We're going to say what sorts of technology goes where. For example, if we're a firm of 1,000 employees, we're going to determine, are we going to standardize on desktop purchases? We're going to standardize on laptop purchases. What are we going to purchase for a data center? What are we going to purchase for service? What are we going to purchase for communications equipment? All that goes inside of the IS environment, where we kind of plainly lay out, this is the equipment we're going to purchase and stuff like that, where it's going to be, inventories, all that sort of thing. And then we have the objectives. Now, unlike a mission, these are going to be a lot more actionable. They're going to be kind of more direct, and they're going to, in some ways, they're going to kind of focus on, these are the goals we want to have. So, for example, an objective could be we're going to have a 5-year lease cycle for employees to have a laptop. And that could be something we'd do. So we'd work with various manufacturers and basically acquire that. There's lots of different ways to go about that, of course, but that's just one example of an objective. Then we have constraints. That's going to be things like, what sort of budget allotment do we have? Do we have $1 million or do we have $20 million? That's going to go in there. How are we going to spend it? Other constraints. What sort of staffing do we have? Do we have 10 employees to support the organization? Or do we have 10,000 employees? Also, what sort of space are we working with? How large is our data center? How large are our distributional facilities? These are all very important things that you would have as constraints. Then, of course, you'd have an application portfolio, and this could be quite long depending on the organization. If you're an organization that basically is just a manufacturing firm, it may not be as long. But imagine you're a firm that has, maybe 50 to 100 different functional units, and each of those functional units has 3 or 4 applications apiece. You could be looking at, anywhere from a couple hundred to maybe even thousands of applications. And for each of those, you'd want to see things like, where is the application stored? How is it installed? Who supports it? Who maintains it? What does our licensing agreement state? How many users can use it at once? How many users can have it installed at once? Those are all very important things. And, again, the application portfolio is going to be quite a large document. It's really going to have every single application that your organization has either licensed to or is purchased. And that's pretty much the whole purpose of it. It's just to kind of have all that information in one place. In addition to that, it's also going to have things about the version that you have access to. Do you have access to the latest version? Are you on an older version? What sorts of updates are there? Are there any sort of security vulnerabilities that we know about? So it's all going to be inside of one central place inside the application portfolio, which is a component of the operational plan. Then in addition to that, we talked about the constraints, how much money do we have to spend? Well, then we're actually going to allocate that money. We're going to say, okay, we're going to spend maybe $1 million on computer purchases or leases. We're going to spend maybe $2 million on server purchases or upgrades. Whatever the case may be, we're going to have a detailed budget where we have basically a line item of each and every expense we're going to have, and that's going to be done inside the resource allocation. Then lastly, project management. That's going to be any sort of ongoing projects that we have at the time or planned projects for the future, where we're going to say what we're doing, why we're doing it. All those sort of project management documents, they're all going to be found inside the operational plan. So if you're a large organization, you're probably not actually going to see a singular document that has the IS operational plan. It's probably going to be comprised of many volumes. I can't imagine that you're going to print off let's say 10, 20,000 page application portfolio. It just wouldn't make sense to. So instead, you'd probably have this inside of some sort of searchable format, maybe a database, maybe internal documentation, maybe in a wiki format. Lots of different ways you could do this, but you're not likely to print it off and have it as a formal Word document or something like that. Any questions about anything so far? Certainly feel free to jump in. Okay. So, we talked a little bit about the different constraints you could have, and that's going to be anything that would limit, your success of a project. So it could be things like money, it could be things like manpower, people working, anything like that. And, there's really three main constraints we would think about. And when we're talking about a project, there's three main considerations. These are going to be cost that we have, there's going to be the time allotment that we have, and it's going to be the scope. In other words, what is the product or project actually going to do? So the whole premise of the triple constraint is that we can maximize two of these, but not all three at once. So we may have a project that we can do very inexpensively in a very short time, but that project's probably not going to do a whole lot. We may have a project that does a whole lot and doesn't cost very much, but it may take us a very long time to do. Same thing if we had a project that didn't take very long, had a very broad scope, it did a lot of things, it would be quite costly. So that's kind of the whole idea of the triple constraint. We can maximize two of these three at a time, and it's really more of a broad spectrum where you can kind of place it anywhere on this triangle, and you could place it directly in the middle. You'll have a project that has a decently good cost, a decently good time frame, and a decently broad scope. But it's not going to be, the best scope you could have. It's not going to be the lowest cost you could have. It's not going to be the quickest timetable you could have. So that's kind of the whole idea of triple constraint. Does that make sense to everyone? Any questions about triple constraint? Certainly never hesitate to ask any questions in here. But in addition to that, it's quite common that you'll run into cases where you'll have competing projects. Maybe there'll be projects where they're going to both have the same goal. They're trying to address an issue differently. That can happen. It could also be where you have just straight up different projects. You have maybe $1,000 to spend, or let's use $1 million to spend on projects. And maybe you have two different projects to choose from, or maybe 50 different projects to choose from. And, you have some set amount of money to allocate to each of those projects. You determine how to do it. Do we fund every single project? Do we do it equally? Probably not equally, but, certainly you'd want to have some way to compare projects. So, financially, we have lots of ways here. We have net present value. That's where we're going to look at the future returns of what we expect to get from the project. That's one way to do it. And, that's basically, we're not getting into the sort of financial analysis behind any of these. Just kind of know the basics of how you would compare projects, just to clarify that. You could also look at the ROI, see what percentage of our return on investment are we going to receive. And, how long is it going to last for, stuff like that. You could also look at the break-even period to kind of determine how fast you will break even from what you spend on the project to what you intend to get back from the project. For a lot of corporations, they have a policy where if a project has more than a 2-year break-even period, it's not going to happen. There can be exceptions to that, particularly when we're talking about things like regulatory compliance, where there will never be a break-even point. But for the most part, if you're doing a project to make money, you'd want to see no more than 2 years before it actually makes money. It's just not feasible to have, a loss that leads on for, 10, 20 years, because at that point, why would you spend the money on it? I mean, you look at the future value of the money, it's going to be non-existent, basically. So, and that's stuff we would factor in. But these are all kind of purely financial metrics. There's another one here, business cases. This is where you would actually do kind of a more complete document where you'd actually kind of outline what will happen inside the project, why it's needed, what it can do, and you're going to do this in a lot more detailed of a format. You can certainly include the different metrics here. You can talk about the net present value of the product or project. And in a lot of cases, you're going to have one common problem in a business case. The problem could be something like, Maybe a firm has a website that's not doing well. So that could be the problem. And you could have several different ways to address it. One of the ways could be we're going to build out a new website internally. One of the ways could be we're going to maybe do some basic sort of quick fixes on the website and kind of see if that's enough. Another option could be we're going to outsource the website to an external firm. And, you could have several other options. We're going to do absolutely nothing. So you got 4 different cases there, and you're going to compare them. And that's what the business case report would do. It'll kind of outline the pros and cons of each approach. And, ultimately, it's going to probably have some sort of suggestion for what the author of the case report thinks that should be done. So those are just 4 ways. There's many other ways to compare projects. Don't think this is an exclusive list or anything, or exhaustive list, rather. But certainly, it's pretty common ways that you'll kind of compare projects and evaluate them. So kind of shifting gears a little bit, we've talked in this class about resource-based view and how it stipulates that for something to be valuable, it has to be rare, people have to be willing to pay money for it, which is another way of saying it's valuable inherently, that it's going to be operationalizable by the organization, and it's going to be impossible, if not extremely difficult, for it to be imitated or substituted. So when we take a look at this, we're going to see that's something we want to consider for information systems. So basically, we want to have dynamic capabilities. That's what this is really showing. So we have the resources down here. We want to make sure they're going to be dynamically capable. In other words, we're inside of a changing business environment. We want to ensure that whatever resources we have can be adjusted to whatever sorts of changes kind of arise. Technology is a great example of a dynamic capability because it can be easily changed and adapted. Whereas, more traditional resources like a building, certainly there could be some retrofitting done to a building, but it's less easy to do. And you also think about if you had maybe a large manufacturing firm right now, that'd be a very kind of non-dynamic capability. You can basically do one thing with a manufacturing facility. You can manufacture stuff. And the kind of flip side of that is, what if there's a case where none of your workers are able to get to the office? Maybe there's a natural disaster. Maybe there's a pandemic. Maybe there is something else that occurs that prevents employees from getting to the office. Well, because your resource isn't dynamic, it's not going to be very useful to you at that time. That's basically what this is saying, is that through dynamic capabilities, you're able to achieve a advantage. And ultimately, of course, you apply your strategy to it, and that's how you actually achieve the competitive advantages, through a dynamic capability. So when we're talking about, purchasing new IT systems, it's important that we remember that. We want to have systems that are going to be dynamically kind of able to adapt to many different things, and they're not going to be so focused on one singular purpose. So one example could be, rather than purchasing a desktop, maybe we'd consider purchasing a laptop instead. That would allow us greater portability. It would allow people to work at home if they need to. It's going to have pretty similar performance. I'm not going to say it's going to be identical, but for the most part, it should be pretty similar. And that's just one example. Purchasing stuff, making these decisions based upon what's going to be most dynamic for the organization. In addition to that, you also want to consider budget. That's kind of a self-explanatory one there, where, basically you have some set amount that you can spend. And, with that, you don't want to go over budget too early. You don't want to purchase stuff that's not going to have a good return. So you just want to make sure that you're doing that. Then in addition to that, you also want to think about, where are we going to put the stuff? We're talking about physical servers. You've got to have a server room. You've got to have climate control inside the server room. You have to have physical access security in the server room. You have to have probably some sort of non-water-based fire suppression system. I think halon gas is a pretty common way to do that. But there are a couple other compounds you could use as well, where basically, if there's a fire inside the server room, you don't want to have the entire server destroyed. So you would instead, sorry, my phone's not on silent there. It is now. But anyway, so the whole purpose is that you have, lots of different considerations to make just for purchasing a server. And, that kind of goes back into the location. If it's a desktop, you have to have an office. If it's a laptop, maybe you have to have a wireless network. There are lots of different things to consider. We're talking about an application. Is this something we're going to host ourselves? Or we're going to install it locally on every system? Or are we going to host it on a server? Or are we going to host it software as a service, where we're not actually hosting it at all? Instead, we're accessing it on someone else's premises. So there's lots of different things to consider there. And that's some of the things you would certainly think about. So kind of regarding this origin of software, there's really 6 major ways that you can actually kind of obtain software. First one is probably the most basic, and a lot of times it's the easiest to understand. It's commercial off-the-shelf software. As the name implies, you can walk into a office supply store and pick up a copy, and you have a license to the software once you purchase it legally, of course. Common examples of that are things like Microsoft Office, maybe some sorts of Quicken software, stuff like that, where it's pretty widespread, and you can certainly easily obtain it. And that's kind of the whole concept. The flip side of that is that's going to have pretty heavy commoditization. We're talking about commoditization from technology, for software in particular. It's both good and bad. It's good in that you probably know how to use Microsoft Office. If you're an accounting major, you probably are familiar with some of the common applications in accounting. But the flip side to that is that you're not going to be able to achieve an advantage through it because anyone can go purchase it. You're not necessarily special because your firm uses Microsoft Office. So that's kind of some considerations there with commercial off the shelf. That's going to differ from turnkey. So turnkey software is basically where you'd purchase a kind of heavily specialized application solely for the purpose of one specific task. This is pretty common in industries like animation, where you'd purchase a very expensive system and you'd basically have it installed and you'd have dedicated support and stuff, but it's going to be quite costly. You're talking, anywhere from $50,000 upwards of $150,000 for basically a single system. So it's not necessarily going to be the most practical approach for a lot of firms. Now, that said, there's certainly turnkey software examples where the software is considerably cheaper than $50,000 for other industries. But certainly it's going to heavily depend upon what the common vendors within your area kind of do. So it's going to vary pretty dramatically by industry. In-house development, that'd be where you'd have an internal team of developers, and whatever software you need, they write. So they have different processes they would go through, but ultimately they're going to basically write whatever application you need. Customized application, that's going to be like some of these ERPs where you have the option to actually do some customization to it. You can certainly have it hosted by them. That's not really what we're talking about here, but regardless, you're going to be able to customize the application for, to better fit your company. So that's basically all there is to say about customized applications. Software as a service is going to be software that's not hosted on premises. Instead, it's going to be hosted by a third party. And you'd access it typically through a web browser, but not exclusively. And, again, it's kind of pretty common, especially for a lot of web applications and stuff like that. Then lastly, open source software. This is going to be software where you can download the source code freely available, and you can basically compile this source code yourself. It's going to be, a lot of times it'll be free, but it doesn't have to be free. A lot of open source applications actually have paid versions of them because you're paying for support. So we think about companies like Red Hat, which were recently purchased by IBM. They're an open source company. They make Red Hat Enterprise Linux. You can freely get the source code. You can compile it yourself. You can make your own Linux distribution in that way. But if you wanted to purchase Red Hat, you'd still pay a price for it. You'd pay a support license, basically. And a lot of enterprises do that. It's a very common enterprise software for that purpose. So again, it doesn't have to be free, but a lot of times it is free. And even if it's not free, you can freely get the source code. That's what open source means. For most other commercial software, you're not going to be able to ever acquire the source code for it. Any questions about anything so far? Okay. So with each of these, I'm going to go ahead and caution myself, really, and say that, the cost is going to differ by product. It's not going to differ by any of these origins. Now, typically speaking, turnkey will be more expensive than commercial off the shelf. But for the most part, the cost is going to differ by the actual product or service that you're being provided. But a lot of times you'd want to make sure that you're considering things like, what is the cost of our different options that we have? What are the support agreements? Do we have 24/7 support? Do we have dedicated support personnel? Is it forum-based? Do we have a number we can call? Do we have email support? What is the sort of time frame for support? In other words, if we had a problem, how quickly can we have it resolved? in a guaranteed way through like a service level agreement or something to that effect. That's certainly things you consider. You consider, where is the software going to be hosted? Is this something we have to host ourselves? Is it going to be hosted externally? Then, kind of going into security. How is the data that the software accesses? How is it secure, that data? It's an important thing. Then you also have things like, if there's a problem with the application and it causes a data breach, who's responsible for that? So that's where you'd have things like a memorandum of understanding, where if you're some sort of a firm that's subject to a lot of the kind of federal regulations like HIPAA, HITECH Act, FERPA for education, Sarbanes-Oxley for finance. If you're in one of those industries, you probably want to establish some sort of memorandum of understanding where basically you, the company that's purchasing, and also the software company you're purchasing it from, you both plainly understand what sort of regulations that the industry is subject to, and that you agree to those conditions. It doesn't have to only be for regulations, but that's a very common use of it. It's just to kind of show that the two parties are aware of what sort of regulations are within the industry. And then also you could do a service level agreement, where you basically just say that the company will agree to do certain things. So maybe there will be a 24-hour support turnaround, where if you submit a work order to them, within 24 hours, they'll have it resolved. Or maybe it's going to be like some sort of a service level agreement where they have some sort of initial kind of contact, where you contact them and they're going to respond within 10 minutes, something like that. Quite common within the industry. And of course, as with anything, the better the support is, the more it's going to cost. So, and then lastly, you also just want to consider who's responsible for problems with it. Is it something that we're going to be responsible with, or is it something that the company that we're purchasing from is responsible with? So, for example, open source is pretty famous for this. Unless you're purchasing a support contract from them, you're responsible for any problems that you run into. And that can be good and bad. I mean, there can certainly be lots of kind of forums and lots of other communities for people who are using that particular software who can help you out. No costs associated there. But do you want to rely on that for your organization? A lot of times the answer may be no. You'd rather purchase support. So let's kind of go back to, if we're using in-house development, some different development techniques we could actually use to kind of aid our development process. So this is a very common one. It's a system development lifecycle. And basically, it's kind of an approach where you start off by determining what you want in the requirements analysis. And like a lot of these cycles, it's going to continue. So you're going to continually evolve. You're going to continually have new versions of things. And let's kind of go through this. So we start off, we collect what requirements we need. So this is where we'd sit down with stakeholders and we'd say, what are you needing to have done? How do you want it to be done? That sort of thing. And you basically just figure out exactly what they need. You come up with a design in the next phase. You kind of say, this is what I think will work. Maybe you build out a quick prototype. And then by the implementation phase, you've already got it built. So you've got something that you're using, you're kind of seeing how it's working, and then you go to the testing phase, you kind of see, how is this working so far? Can we make improvements to it? What sort of improvements should we make? You make those improvements inside the evolution phase, and then, based upon that feedback, you go back to the requirements phase. And it's sort of a thing that's kind of ongoing, where you'd have some sort of a business application that you're kind of using kind of in a repetitive way like that. So you're starting at the requirements, kind of figuring out how it should be built. You're building it, you're seeing how it works, and you're improving upon it. That's all this really is saying. It's kind of similar to the DMAIC process. They're all kind of related in that way. So we just went through these phases, but let's actually talk about some implementation strategies. Or I wouldn't necessarily use the term strategies, even though I did use the term strategies in the slides here. I would probably say implementation approaches or implementation methods, just so we don't confuse strategies with business strategy. So let's go through each of these. So basically what I did here was I usually use a document camera inside the lecture hall to, kind of have a piece of paper there and I write it out. But, it's not really going to be feasible right now, given that I'm not in a lecture hall for one thing, and, given that I'm using Teams to present this in another. So I just kind of scanned in one of my old pages that I used to kind of show each of these implementation strategies. So basically what we have here is at the bottom, we have 0%. That is to say the system is being used 0%. And then at the top, it has 100%. That is to say that the system is being used 100%. And I've got two different colors here. I have This is going to be the black ink is going to be for the old system, and the red ink is going to be for the new system. So basically, we look at this, we see for direct conversion, we have our old systems being used 100% of the time until all of a sudden it's not being used at all. We basically just flip a switch and we go from the old system to the new system like that. It's quite simple. So we see the new system is at 0% utilization until the old system is cut off. Then it's used 100% of the time. So if we were to do an implementation like that, we would basically literally just one day cut off the old system and turn on the new system. It's going to be used in some cases, but for software, we typically want to avoid that, because what if there's a problem with the new system? How are we going to actually identify that problem? Seriously, someone answer, how would you identify a problem with the direct conversion? So, you can imagine that if you were a company and all of a sudden you'd have a new system and you realize that the system had a lot of problems, you would find out the hard way, basically. Everything would quit working. I mean, that'd be quite devastating. So with pilot conversion, we actually have some sort of a testing phase where we start off with 100% for the old system. Then we do a pilot testing period where we kind of see, we're going to slowly switch off, one group of people, and they're going to be kind of our beta testers. They're going to kind of use the system earlier, tell us what needs to be improved, tell us what's working well, just give us some good feedback like that. And then after we get that feedback, then we're going to basically turn the key, just like we did in direct conversion, and go all in for the new system. But we do have a testing phase. So basically, we're going almost all for the old system until we do a pilot testing phase. Then after the pilot testing phase is done, then we fully convert the system to the new system. This is going to differ from phase conversion. Phase conversion is where we would basically implement people within phases to the new system. So we have a system in place. We're going to use it. We're going to maybe get one functional unit off. A lot of times this can be done departmentally. So maybe we start off with getting our accounting people transitioned over to the new system. Then we see how that goes. Depending on how it goes, we get a next group, kind of move them over, and so on and so forth, until we ultimately have our entire organization using the new system. So the new system will end at 100% utilization. These are hand-drawn graphs. They're hand-drawn by me at that. So, but believe me when I say this is supposed to be 100%. I know it looks like it might be a little more than 100%, but certainly keep that in mind. So with phases, all we're going to do is just, as the name implies, we're going to take this implementation, and instead of doing it all at once, instead of turning a switch one day, we're just going to do it a little bit at a time. Then in parallel conversion, we're basically going to have both systems going 100%. So this could be where we have maybe like a site redesign, where people can kind of select, do they want to use the old site or the new site? They can select it, but both systems can run 100% of the time. There's going to be no issues with data inconsistencies. It's all just going to work, but basically either way people prefer. So that's basically where you'd use it. But there's not really going to be any transition period. Obviously, eventually the old system will be phased out, but by the time that happens, it could be the new system's phased out as well. Any questions about those? You'll probably see at least one or two test questions about the different conversion approaches there. And by the way, I do want to make note, I did scan in and I uploaded I don't remember exactly what I called it, but it should be in Canvas in Unit 2, where I basically just have all these different pictures on a single page. So yeah, certainly check that out. But yeah, that's basically what we're doing there. But there's a lot of other approaches we could take to developing software. We could use joint application development. This is basically where we get all the parties involved, we sit them down, and we basically have everyone agree on the requirements. It's not really feasible to have everyone sit down together all the time. We could, of course, use online meetings and stuff, but even with people's schedule, it can be very difficult. So I would say that's probably one that's less commonly used in industry, but that's what it is. We could also use rapid application development. That's where we basically kind of implement little bits at a time, where we build out part of the system, we implement it, we see how it goes. That's going to be quite common for things like a ERP, where we're going to basically be able to, kind of easily build out little modules. So that's basically what rapid application development is. And the dangerous thing about this is we're going to test it on our main system, whatever we actually have. We're using it for production. That's what we're going to be testing on. So it's kind of a dangerous approach there. Then lastly, we have Agile, where basically we're going to split everything kind of up, and it's going to be very similar to rapid application development, only we're not necessarily going to inherently be testing on production equipment. So that's kind of the main distinction there. But it'll still be kind of done in different iterations. So some other development tools we could use. We can certainly use prototypes. It's where we basically have a system. It's not really an implemented system or anything, but it kind of shows. Maybe we do an interface prototype where we show what the system could look like. Maybe we would do kind of a working example where we kind of show how the data may flow throughout the organization. You could probably consider some charts to be prototypes. It kind of depends on your perspective there. But it's basically just something in place where it's not really implemented, but it's what it could be implemented to be. And that allows you a lot of feedback and a lot of maybe criticism, ways to improve the system early on. Also, we could use stuff like computer-assisted software engineering tools. And this is basically just where we have different tools, oftentimes stuff like an integrated development environment, where we kind of have assistance in writing the code. We're not having to write everything completely from scratch. Maybe it helps us out with some of the basic things, especially stuff like the structure, syntax, that sort of thing, kind of help us out, kind of help in compilation. All that sort of stuff is going to be aided in. We also probably use some sort of object-oriented development language, especially for a lot of modern programs, where basically you can have stuff reference as objects instead of done procedurally. Kind of aids in having the code be easier to understand, to humans at least, as opposed to procedural languages where you'd have to basically, every time you did something, you'd have to basically redo it. You can't reference existing stuff as easily in procedural programming. Again, you probably won't see most of this stuff on the test in terms of, object-oriented development or computer-aided software engineering tools, but that's just what they are. So now we're going to get into the technology guide, which again, this is going to be a pretty short technology guide. It's only a couple slides, just kind of goes through a little bit more about technology, for software at least, and kind of shows how organizations use it, what it is, that sort of thing. So at the most basic level, we have hardware. We talked about what hardware is, last technology guide. Well, this one's about the software. It's the instructions for hardware. It basically tells the hardware what to do and how to do it in a lot of cases. So this can be things that are very low level, like an operating system, like a driver, or it could be things that are very high level, like an application that we typically use and kind of think about. And that's going to be quite beneficial for organizations because basically software allows us to make common applications that can run on a multitude of hardware. In other words, we're not limited to having one specific piece of hardware. You go earlier on in computing, and a lot of times applications would only run on certain equipment. So we can certainly have web applications as well that can run on almost any device, particularly things like mobile devices, phones, tablets, Chromebooks, Windows devices, Mac devices, Linux devices. They can all run the same stuff if we're using web applications. So that's one of the benefits there. Also, we talk about software defects. A software defect is just going to be a bug. So basically, we'd have some sort of a problem with our software. It can cause a lot of problems for our company. So imagine we had an application, we're a bank, and the banking application didn't correctly maintain people's balances. I don't think many people would be happy about that. So that's certainly something we wouldn't want to run into. And then also have an example here on software licensing. Now I want to do a quick poll here. So everyone go into chat real quick. And I just want to do a quick poll. I'll give you extra credit for participating in this, of course. Imagine you were a nuclear power plant. So you're working in a nuclear power plant. And you want to listen to some music while you're working. So assuming that your organization is okay with it, you could use iTunes to listen to music. Let's say you had a Mac device. You want to do that. Do you think that's within Apple's terms of service in their software license to allow you to listen to music just using headphones? Just a simple yes, no inside a chat. So it's a little bit of a trick question. I'm in the middle of a PowerPoint slide here, but if you actually click on that link and you do a Control F for nuclear, you'll actually see that they don't allow you to use their software, specifically the iTunes application, to listen to music inside of a nuclear facility. So that's kind of an interesting thing. And, would they actually go forward and, bring a civil suit against you for doing so? I don't believe they have to date, but they could. And, if we're a firm, we'd want to avoid a situation like that. So we would actually want to make sure that we carefully review what our application's software licenses say. So, for example, if we're using a piece of software that we downloaded for free, inside the software application, it says it's not for commercial use, and we're using it in a commercial environment, that could be a problem. We could certainly face some civil action against that. In addition to that, we want to make sure that we're in full compliance with whatever the license says, so that we specifically avoid those sorts of circumstances. So that's a kind of tricky question there. I won't put anything like that on the test, unlikely to at least. But yeah, you just want to make sure that you're very careful. And you do that kind of like I said earlier on in the lecture, where you'd have an application portfolio. And that's where you would actually review your applications and see, what does the application software license say regarding things like how many devices can it be on at a time, what sorts of things can we do with it, what sorts of things can we not do with it, how do we update the application, where is the application housed. That's all going to be within there. So I have one more slide here. And this is just kind of talking about, applications versus system software. So basically, when we have a system application, like, an operating system or a driver, it's going to be very low level. It's going to be very close to the hardware. So, the hardware device has, various drivers that, kind of interface with the operating system and allow applications to be installed and run on it. And then you're actually going to be interfacing directly with the applications. So basically, just kind of look at this chart here, and you see that, you're going to be facing with the applications. Sometimes you'll be interfacing with the operating system as well. So I would probably put another little arrow going from user to operating system, but I didn't make the chart. Then also drivers are going to be interfacing kind of with the hardware and the operating system. So that's pretty much what we see here. The lower level something is, the closer to hardware it is, the less likely you are to be directly interfacing with it. Any questions about today? So just kind of wrap up, we talked about IT planning, we talked about application sourcing, system development lifecycle, as well as the technology guide for software.
Can you go back to that last slide for a second?
Yeah, sure.
Okay, I'm good. Thank you.
All right, any questions? Well, guys, that's all I had. I certainly hope you all have a great day. We'll pick up tomorrow, kind of go through whatever you guys want to ask questions about. I'll be ready for. But other than that, have a great day. And I'm going to stick around in case anyone has any questions.